Hello everyone, my name is Samsoo, and today I will talk about my project, which is hybrid recommender system. I built this project to predict user rating for product and recommend items that user may like. I use a hybrid model, which means I combine different models to get better prediction. I will explain the task, how I built the model, and how I evaluate them and model result. Also, the cold start problem and why I mentioned method is useful. My main goal is to predict user rating from 1 to 5 stars. I used the Amazon subscription boxes review dataset, which has more than 16,000 reviews. I treated this as a regression task, which means I predict a number, the rating itself. I evaluate my model in two parts. First one is accuracy. I use RMSE, which gives higher penalty for big errors, and MAE, which measures the average error. Second ranking, I use hit at 10, which checked if the top recommendation items includes items user actually like, and NDCG at 10, which also considers the order of items, giving more credit if relevant items are higher in the list. So this is my summarization for this project. And I first explored the data to understand the user behavior and review patterns. Um, so as you can see here, most ratings are 4 or 5 stars. Yeah. Most users wrote only one review, uh, and only a few users wrote multiple reviews like this. Recent review lengths are quite vary. I noticed that longer reviewers uh, sometimes have slightly lower uh, rating. I think it's I think this happen because users tend to write longer reviews when they are dissatisfied and want to explain their concern. This tells me that simple user-based collaborate filtering alone is not enough because most users have very few reviews. Um, this is also called the cold start problem. When a user is new or has very few interaction, the system has little information to make uh, personalized recommendation. Contents-based model like TF, IDF, or word to back are more reliable for cold start users with multiple reviews help me train user embedding for personalization. I built my hybrid system with three main parts, two based models and one meta model. Uh, the first based model is TF-IDF Reach, this one. It uses review text to predict rating. This works for all users, even though with only one review. The second based model is word to back, which It converts words into vectors and averages them to represent each review. This captures the meaning of words and phrase. The meta model is a residual stacked neural network model. It takes user ID, item ID, and the base model prediction as an input. It learns the residual error, which is the difference between real rating and the TD-IDF prediction. This helps correct the base model prediction and personalize recommendation for active users. In short, I used base model to handle general prediction and the metadata model to adjust for user and item pattern. This combination improves accuracy and personalization. So metal model architecture input is user embedding, item embedding, and here scaled TF IDF rich prediction is input. And like my meta model is the goal of my meta model is reduce the residual from those input. So I'm gonna explain evaluation metrics. I compared four models. Baseline, which is a simple average of user and item rating, and TDIDF reach, which is contents-based prediction, or to back reach, which is semantic contents prediction. And lastly, I compared stacked ensemble, which is the hybrid model combining the previous ones. See, this is the result from the project, and the stacked ensemble will achieve the lowest error. RMSE was 0.8, about 0.8, and MA was about 0.68. Heat at 10 was around 0.64 for all model, and NDCG at 10 was almost 1. Uh, these differences are very small, so they do not carry much practical meaning, mainly because most users have only one review. This shows that combining base model with residual learning gives better accuracy than using any single model. Accurate uh, mm, single model. Accuracy in this context means how close my predicted rating are to real rating. So let me explain about key observation. The hybrid model works well for several reasons. Mm, First, mm, the contents-based model like TF, IDF, and Word2Vec gives good prediction for all users, including cold start users who have few or no reviews. Secondly, the residual stack neural network uses embedding for active user, making personalized prediction. Third, combining multiple source reduce errors and improve stability. Uh, Practically, this means new users get reliable recommendation from TF-IDF reach, and active user benefits from personalized correction through the meta model. I believe I balance general precision and personalization, making the system robust for all user types. So this is my last part for the project. So um, there were lots of studies about customer recommendation, and many previous studies used single model like TF, IDF, or word-to-back matrix factorization, or large model like BERT. But my differences are I used hybrid model combining multiple contents based model and collaborating filtering. I used stacking based meta runner, which automatically learns the best combination of base models. This is more accurate than simple averaging. Also, I use lightweight model, which are very fast to learn and easy to interpret. Using multiple model together fixes each other's weakness, improves prediction accuracy, and give better personalization. So yeah, so this is my conclusion actually. To summarize, I built a hybrid recommender system that combines TF-IDF, word-to-back, and residual stacking. The stack ensemble is the best model with RMSE 0.98, and base model provides general prediction, while the meta model personalized for active users. This approach is simple, interpretable, and effective for different type of users, including cold start users. Thank you for listening.